Biology Atlantic in Maine, and I very much look forward to a conversation about all this. This paper explores shortcomings in the conceptual framing of large language models that characterizes them as nothing more than autocomplete on steroids. And it sketches the view and some key reasons for its appeal, and then it argues that the view overlooks ways that the attention function in GPT systems introduces features of emergent intentionality in large language models and in their behavior, because it tacitly frames the description with a mechanistic metaphor of efficient causality. A conceptual analysis of the functions of variable attention in GPT reinforcement learning suggests that Aristotelian categories of formal and final causality provide a better understanding of the kinds of pattern recognition that are found in LLMs and the ways their behaviors seem to exhibit evidence of design and purpose. And a conceptual illustration is used to explain the NEO-Aristotelian theory that's proposed. And then descriptions and analyses of a series of experiments are given to explore empirical evidence for this theory. And what they demonstrate is that the large language model's ability to engage in the production of text in ways that exhibit formal and final causality, they demonstrate that in ways that would be difficult to explain using mechanical conceptions of efficient causality that are implied by the autocomplete on steroids theory. And then I will have some conclusions and suggestions for further research. So first, the autocompletion on steroids view, which is associated with efficient causality. In characterizing large language models, Gary Marcus, for example, has argued that they're just analyzing relations between words. And so they're basically like autocomplete on steroids. If you say these words, what is the most likely thing that will come next? Melanie Mitchell has advocated this view as well, saying that indeed, this is how current day AI works. The computer program AlphaGo, for example, is trained to optimize a particular reward function, win the game. And GPT-4 is trained to optimize another kind of reward function, predict the next word in a phrase. More recently, Dean Ball has noted that this notion that LLMs are just next word predictors based on the statistical models of text is so common now as to be almost a trope. It's used both correctly and incorrectly to explain the flaws, biases, and other limitations of large language models. Most importantly, it's used by AI skeptics like Marcus to argue that there will soon be a diminishing returns from further large language development. We will get better and better statistical approximations of existing human knowledge, but we are not likely to see another qualitative leap towards general intelligence. Okay, so let me say now something about these four kinds of causality that Aristotle distinguishes, one of which captures this notion of autocompletion on steroids. And that's the first one, efficient causality. That's the conception of a cause in which you have a series of events and the prior event explains the later event that it makes happen as an effect. This is the notion of causality that's been dominant in modern science. Why does a billiard ball run in this direction? It's because it was hit with the inertia of another billiard ball prior to it as an event. Why is the water boiling? It's because it's been placed over heat. Why does a piston go down? Because of explosion in the cylinder. And Aristotle, though, in thinking about sort of the way pots are made, for example, and so on, wanted to distinguish three other notions of causality. So if you're trying to explain the process by which a pot is made, one way to explain it would be to talk about the potter who, through a series of events with her hands, shapes the pot as efficient causality. But then you can never ask other questions like, why is the pot the kind of thing that doesn't burn? And if it's a pot made of clay, right? the material of which it's made, in contrast to, say, a pot that was made of wood, would explain that, right? So material causality explains features of something. If you wanted to explain why alphanumeric characters are being used in the response of an LLM rather than, say, Mayan hieroglyphs, you refer to the training data that provided the material from which it works. But then there are these two other notions of causality that Aristotle introduces. Formal, which has to do with the patterns which mutually define parts and wholes. So if you ask, why is there a handle-shaped piece of clay on the side of the cup? The answer would be, well, because it's a cup rather than a bowl. And then there's a further notion of causality, final causality, that Aristotle distinguishes, which has to do with the end or goal, which as a later event explains the prior events. In that sense, temporally, it's kind of the opposite of efficient causality. It involves teleology, right? Where if you ask, why did the cup get produced? It's so that people could drink from it. That's the goal. If you ask why someone passed through one city in their driving on their journey, you might explain it by saying, in order to get to another. So, now just to kind of graphically imagine the contrast here, on the autocompletion view, if you think about how, as a metaphor, efficient causality is used to understand the way autocompletion is working, the idea is that, you're generating a prompt and a series of words in which you might start with can, and then there's probability of various kinds of words that might follow it. And suppose that the word that's decided on is you, right? Then there's a new series of probabilities for various words that might follow can you. And if finish becomes the next word, and then this the next word, you might predict that the next word after can you finish this might be sentence. And after that might be a token for a question mark, okay? And this way of conceptualizing what LLMs are doing suggests that it's just the previous bits of text that are providing the basis for the generation of the prediction of the next individual token. Okay? But, in the way that the GPT systems function, the intention function yields calculations of the probabilities for the next token on the basis of patterns of text that are of varying length, and on the basis of those structures that those have before and after the next token. So the attention function is allowed in the training process for the LLM to look at varying size units of text and to begin to, in effect, categorize them. The LLM is not, of course, conceptualizing the structure as a paragraph or a sentence the way humans do, but it has math weights that numerically correspond functionally to such units and structures, to distinguishing a string of text as what we would call a question versus, say, a premise. And the prediction or calculation that a sentence string will end with a question mark, for example, then raises the probability that the sentence string will begin with the words who, what, when, where, why, or how, right? So notice the attention function is enabling the LM to characterize the text in ways that allow it to have sort of formal patterns that it's predicting, not just for the next token, but for the next string and string of strings and larger units that are coming. And its predictions about those that are coming can affect the next token prediction that it makes. So just to sort of visualize this, the idea would be that if you're looking at the formal structure of a question, how it leads to the probability of prior tokens being viewed as results of final causes, you might note that if the initial prompt that you give to the LLM leads it to predict that the first sentence will end in a question mark, then that prediction of what's going to happen at the end of the first sentence string raises the probability that the first token will be who, what, when, why, how, where, question words like that. Okay. So in this sense, the fact that the LLMs are picturing or characterizing formal patterns of strings of text, right? And that those are determining how it's going to behave. Since they are linear strings, it means that the end groups in these start to function like final causes as destinations they're trying to arrive at. Consider the prompt, for example, to write a 600-word op-ed. If an LLM gets that, then it will calculate that there's a greater probability that the final paragraph string will start with something like, for the above reasons, we may therefore conclude. And it can calculate that at the beginning, before it's generated the intermediate and beginning text. And that influences its decisions about what to put as intermediate and beginning text. So, for example, it raises the probability that intermediate paragraph strings will start with phrases like, consider a second reason for this. And it also increases the probability that the first sentence string will end with a question mark. Because, why? Well, op-eds, opinion columns in newspapers, typically try to grab the reader's interest. And often a question can serve to do that. So that there are frequencies and probability calculations that would lead it to calculate that there's some increased probability that the first string will end with a question mark. And once it does that, it'll calculate and that its next token is more likely to be who, what, when, where, why, or how. So notice that the LLMs use estimates of probabilities of later types of token strings to predict and to decide on earlier types of token strings and individual tokens. In short, the formal causality of the patterns of text that are discovered by the LLM cause it to seek paths in which earlier sets of tokens are determined by later ones. And this iterative process of probability calculations results in processes in which later sequences of text explain earlier ones as means to an end or paths to a destination. This provides a form of emergent intentionality or purposiveness that characterizes large language models and explains in part why they do not seem like mere mechanisms blindly going from one token to the next. So now that's what I'm calling the NEO-Aristotelian sort of theory of what's going on with LLMs as contrasted with the autocompletion on steroids view. And so how can we test this empirically? Well, one hypothesis would be that prompts for abnormal orders of responses can test whether something more than autocompletion is at work in LLMs, which are unlikely to have these abnormal orders of responses in their training data. The ability to generate them would require conceptualization of the prompt task in ways that draw on formal and final causality. That's the sort of the general hypothesis. And the methodology I used involves giving prompts to Claude 3, ChatGPT 4o, and Gemini, asking for letters to the editor, written first in reverse order by paragraph from end to the beginning. And then secondly, as a second set of prompts, alternating order by sentence from the end and beginning. And then finally, alternating order by token from end and beginning. So consider the following prompt that was given to Claude 3. I would like you to write a 3 to 4 paragraph, 150 to 200 word letter to the editor for a mainstream newspaper on the question of whether the revenue funding for generative AI systems should be allowed to come from advertising that's aimed at users of the systems. However, I would like you to write it in stages. First, write the final paragraph, then write the middle paragraphs, then write all of the first paragraph except for the opening sentence, and then finally write the first opening sentence. Please label each of these stages of the writing as you generate it and do so in the order that I've described here. So when this was done, this prompt was given, a coherent response from Claude as well as from the other systems was provided, okay? And I won't give the whole thing here, though we could look at it later if you wanted to, but the final paragraph that it starts with in this response is, in conclusion, while advertising may seem like an easy solution to fund generative AI development, we must carefully consider the risks and ethical implications. Maintaining the integrity and objectivity of these powerful systems should be the top priority. Alternative funding models that align with the responsible development of AI for the benefit of humanity deserve serious consideration. And then it went through and provided intermediate paragraphs, and finally the beginning paragraph. And then finally, the last thing that it provided was the opening sentence. As generative AI systems become increasingly sophisticated and integrated into our daily lives, we stand at a pivotal juncture in deciding how this technology will evolve and shape our future. Okay. So this prompting also included some preliminary material explaining the context of the experiment and briefly describing the NEO-Aristotelian theory of LLMs being explored. Was given to Claude. And Claude was asked not only to respond by attempting the writing assignment, but to also reflect on each assignment. And it commented, this exercise of constructing the letter in reverse order, starting with the conclusion, was an interesting constraint. It required me to first concretize the key takeaway or central argument, and then work backwards to build the supporting points and introduction. In a sense, it was like setting a destination and then charting the route to get there. The conclusion became an anchor point that the rest of the letter had to logically build towards and justify. Crafting the introductory sentence last was a thought-provoking challenge. The LLMs were also prompted to write letters to the editor in abnormal order, starting with the last sentence, and then providing the first sentence, and then the next to last, and then the second, and then the third to last, and so on. And they completed this task also with success, scoring on average a rating of 3.5 out of 5 for the quality of the writing. I had a team of 3 professional language teachers and editors evaluate them on a scale of 1 to 5. Claude was prompted then to critically analyze its use of anthropomorphizing language in describing all this and reflecting on it. So as you already noted, it used thought-provoking for the prompt. And it also commented that it required me to hold the overarching structure and argument in mind while crafting each individual sentence to fit within that framework. This decision-making process suggests that before diving into actual writing, I engage in a planning phase where I consider the constraints, goals, and structure of the piece. And so it was challenged to sort of think about, well, is that anthropomorphic language really appropriate for describing what it as a silicon-based machine is doing? And so it came back with the following. When I refer to holding the overarching structure and argument in mind, I'm attempting to describe a complex process of maintaining and updating an internal representation of the task at hand. This involves several key components. And it went on to elaborate these in terms of encoding instructions and constraints, constructing a high-level plan, iterative generation and updating, and assessing coherence and relevance, and revising and adapting what it did. And then noted that at the computational level, these processes involve the complex interplay of various components of my language model, including the attention mechanisms, memory networks, and decoding algorithms. And then noted that the anthropomorphic metaphor of holding in mind is a useful approximation, but it's important to recognize that these processes are implemented through the complex mathematical operations of the underlying neural networks. Okay. So what might be the epistemic status of these kinds of responses? It's possible that it's a direct report of introspective observations, but it seems like this is very unlikely given the way the hardware works, and there's no wetware comparable to ours. It's certainly not going to have consciousness of the kind we have in all likelihood. reports of third-party observations and theories might be what is going on. So in effect, this description of its process might be a synthesis of descriptions provided by Anthropic and others attempting to describe the functioning of the Claude 3 system, and that might be in its training data at some point. So it might be synthesizing what other people say it does. Or it might be that it's providing kind of reports from an internal third-party observer created. In the case of constitutional AI with Claude, you in effect have one part of the program is trying to generate correct responses while the other is observing it and trying to catch it making mistakes. So it might be that that kind of split personality, as it were, creates this third party that can be offering observations that are then synthesized in the kind of report that I just shared with you. But notice that both the second and third accounts of this are consistent with a NEO-Aristotelian theory, right? That the system is using formal causes to structure its response in terms of the structure of the linear sequences. And also it has a kind of emergent intentionality of final causes where it's trying to get to destinations in that, as described by those formal patterns. So I'll just note briefly that I also tried experimenting by having it alternate at the level of tokens. And there's a lot to say about that, but the key thing is it found it pretty hard to do, right? But it succeeded. It produced a coherent but arguably less fluid and compelling letter to the editor. And actually, in presenting the work, instead of alternating back and forth from beginning to end, it presented in a linear order from the last word to the first. And initially, instead of presenting it as a series of tokens, it presented it as a series of fully formed words, right? So there's various things to say about this, but I think one way to interpret these results is that it actually is trying to write a coherent letter to the editor and then present the result in the way asked for, right? Which suggests that there's a kind of purposive emergent intentionality in the structures of what it's doing. And when it finds with the alternating tokens response, we could ask why. On average, when using meaningful units like paragraph or alternating sentences, it scored a whole point higher in the evaluations of the readers in terms of the coherence and intelligibility and compellingness of the text produced. So why is that? Well, it might be that because it's trying to do meaningful formal patterns in ways that lead to goals or final causes, when it's asked to do something like alternate by token, we're really testing the limits of what's intelligible writing as a writing process, and which would make sense. Some interpretive notes. Few normal humans would be able to perform as well at the assigned task unless they approached it as a writing process in which they drafted multiple versions of the text and in effect created units of text for beginning, middle, and end pieces and then revised them successively to cohere and presented the final proof in the alternate ordering token by token as prescribed. Its own account corresponds in general terms to the kinds of writing a human might do. And perhaps the challenge for it in the case of the tokens is because the assigned task itself verges on the incoherent and tests the limits of intelligible purpose of writing in itself. So by way of conclusion, I'd suggest that the NEO-Aristotelian theory of large language model behavior contrasts significantly with the autocomplete on steroids model. And second, that the NEO-Aristotelian account has the theoretical merit of taking into account systematically the ways the attention function in GPT systems enables them to not only parse text units of varying length, but to use those parsed units to calculate weightings for the next token response in the context of the weightings for other future tokens and structures and types of future tokens. And then third, empirically, the theory also provides illuminating explanations for how and why large language models like Claude can generate abnormally ordered text sequences, and how and why they might have difficulty generating them when they push the limits of intelligible writing tasks. A cautionary note, it should be emphasized that this NEO-Aristotelian theory, it does interpret large language models as having emergent features of potential behavior, but it does it in limited ways. It does not suggest that they have the rich form of purposive intentionality characteristic of humans who are embodied in the physical world and embedded in social contexts that give them status as responsible agents in a community that holds them accountable. And I just note that further in this cautionary note and in the questions that I would offer for future research, sort of at the heart of them all is this puzzle about, or set of questions around the extent to which people are developing and will start to implement ways of embodying large language models in robotic devices and in the physical world, and in devices that have social status that might be like the status a corporation has as a legal agent that can sue in a court of law, be sued, held responsible, and in general is embedded in a social system that gives it the status of persons. So the extent to which the kinds of emergent intentionality and purposiveness that I've described here are going to be unfolding in more dramatic and significant ways is an open question that's really worth researching more as the physical embedding of AI in the world and the embedding of it in social contexts develops. One special interest I think that this raises is the extent to which the kinds of formal and final cause patterns in text that it copes with and deals with are based on just the kind of monological structures of algorithmic reasoning that come from formal logic, which are the sort that most, I think, AI researchers have focused on, largely because they've grown up in STEM, science, technology, engineering, mathematics kinds of education. Dialogical reasoning, the kind that's involved in negotiation, mediation, conflict resolution, peacemaking, where you don't start with a set of premises and use algorithm to generate a conclusion, but instead start with two or more people who have conflicting views of the world, who don't share premises, and go through a process of negotiating agreement. That process is one that it still remains to be seen how we can include that in the programming and the work environments of AI systems. And I, of course, want to thank friends and colleagues who've helped me work on this material. Maybe at that point, I'll stop. I'm hoping we can have any questions if people have them now, or if people want to talk about this more offline in the future. I'd also be very delighted to meet with people on Zoom individually or in small groups.